In the last video, we started taking a look at how do we take care of graphs to be able to graph and then label axes and do multiple functions on the same graph and to plot those. In this video, we're going to start taking a look at a few more features of graphs, particularly subplots and scatter plots. So a subplot allows you to plot multiple graphs next to each other or on top of one another. And this function subplot m comma n comma p, that just tells you a matrix. So m and n are the number of rows, n is the number of columns. So you get an m by n grid. And for instance, let's say m was 2 and n was 3. Then you would get a 2 by 3, and p would be the numbers 1 through 6 because there would be 6 different possible positions. So this p is just basically the value in that matrix that you're plotting in what position. So the command is pretty easy. So every time you want to use a subplot, you just basically start by saying the number of rows, the number of columns, and then what position. So first position, second position. And you can usually use the easy plot function to work nicely. Now, if you want to start mixing the types of graphs like scatter plots as well as functional plots, then you might want to use the vector plot to make it a little bit easier. Scatter plots are pretty easy to do in Matlab. If you have a same dimension pair, so in other words, ordered pairs, so you have to have 5 and 5, so 5x's and 5y's, what you could do is you could store the x values in a row vector, the y values in a row vector. So right here, we define a row vector for x, we define a row vector for y, and then we use this function plot. And then the third parameter, so we have plot x comma y, so that's the first parameter, second parameter, so x values versus y values. This third parameter is going to be what type of marker that you'd like to put. Now notice, don't use a 0. This is the lowercase letter O. But these are all the different types of markers that you can use. All right, so if you're plotting multiple sorts of variables on the same plot, then you can just go ahead and use different markers for those. And in the next example, I'm going to show you that what you can actually do is you can plot a function on top of a scatter plot or vice versa, to be able to try to work with those and try to see if there's an association between a function and a scatter plot. So we're going to look at a couple basic examples of this before we move on to three-dimensional graphing. So let's write some Matlab code, and we're going to plot 4 functions over the domain -4 to +4. And we're going to use the subplot function to plot them from left to right. And we're going to title and we're going to label appropriate. All right, so here's our 4 functions: arctan, e to the x, 0.3x squared, and 1 over x. And we're just going to put them right next to each other. All right, so here's what we're going to do. We're going to use the command subplot. Well, first of all, let's do a sims variable. So let's just use easyplot to make it easy for us. We might as well. And we're going to use the subplot function. So we need 4 graphs. So I'm going to use the function subplot, and I'm going to say 1, 4, 1. Now that's the first position. It's 1 row, 4 columns. So we're basically going to have them moving from left to right. And remember, the first function that we had was going to be our good old arctan of x. So we are going to do easyplot, and we're going to have arctan of x, and it's atan, not arctan. And remember, the domain that we suggested was from -4 to +4. So I'm going to say bracket -4, 4. And I'm going to close that out, and we're going to have an x label. I'm going to call it x-axis, and y label. Let's call that surprisingly y-axis. Right. And let's have a title. And let's call it arctan. All right, now what I'm going to do is I'm just going to copy and paste this, and instead of 1, 4, 1, let's use 1, 4, 2, because that means it's the second position. And we're going to use exp of x, and let's just call this exp of x. And I'm going to plot this right now just to show you what happens with this. By the way, easy plot is just saying it's not recommended, but I've never had any issues with it. So I'm going to run this, And it might take a few moments the first time you run it. And notice the graph that we get out of this. All right, so the labels are on there, and we get the graphs side by side. But notice that we have 2 empty spaces, and that's because we designated a 1x4 matrix to put these out at. All right, so remember our other 2 functions. We had the function 0.3x squared. So I'm just going to change this to 3. I'm going to change this to 0.3 times x squared. And this is 0.3x squared, just for the title. Right? And then finally, we can cut and paste one more time. And this is in the 4th position now. So we're going to have the 1 over x. And we have 1 over x. So let's see what this looks like. So we're going to run it, and we're going to wait a moment. All right. And I'm going to expand this graph to make it a little bit nicer. All right, there we go. So we get these 4 graphs. Those are the titles. Really nice and pretty on those. We have x-axis, y-axis. And of course, if x and y had some sort of contextual meaning, like time versus velocity, or something of that nature, then we could certainly label them as such. Okay, so pretty cool. And of course, we can always just try to do some other stuff with it if we wanted to, but these are good enough for right now. All right, now let's take a look at an example of using a scatter plot. So I'm going to get rid of all this nice code all gone. Shameful. And in our example, it says, first of all, we want to create the order pairs and store them in row vectors. Then we want to use a subplot from top to bottom this time. And we're going to graph the appropriate labels as well. So we need a scatter plot for this data. Right, so that's easy. We're going to plot a function in the other scatter plot from -3 to 4. And then finally, we're going to draw the function and the scatter plot on the same graph. Right, so let's get to it. First thing I'm going to do, I'm going to define a variable x, and I'm going to define that as my row vector. And now look at the x variables and note, or the x data, and we have -2, -1, 0, 1, 2, 3. So that's what I'm going to store in my row vector. So we have -2, -1, 0, 1, 2, 3. Don't need a comma, but I'm going to put a semicolon after that to suppress it. Y, I'm going to put the y coordinates in. So that's 0.4 or 0.1, excuse me, 0.4, and then 1, 3, 8, and 20. And I'm going to suppress that. Now I'm going to type in plot, and I'm going to plot x, y, and let's see what this does. All right, so let's just run it. All right, and notice what we get is we get a scatter plot. Now I didn't put any labels or title on it or anything like that, but it looks like an exponential function. So let's go ahead and label it. So we're going to do an x label. So x-axis, actually we could just call it x data. And we'll copy this, and we'll just have some y data. And then finally we have a title, and let's call it scatter. All right. Now, that only plots the scatter plot. Now we need some subplots. So we need 3, right? Because we have 3 graphs. So 3, 1, 1. So that gives us 3 rows, 1 column, and first position. Now we have to plot the function e to the x. So I'm going to do this. I'm going to call I to be equal to, and if you remember from our function or from our instructions, we're to plot the function from -3 to +4. So let's just make a domain, and I'm going to use the row vector this time because row vectors seem to look a little bit better. So -3.01 colon 4. I'm going to suppress that, and let's call j equal to exp of I. All right, so now we have a function I and j, and I'm going to plot that. So now I'm going to change this to 2, so it's the second position in the subplot. I'm going to plot I comma j, and we have, let's call this x-axis, y-axis, and let's just call this exp of x. All right, so I'm going to run it. And so now they're on top of one another. Here's our function, here's our scatter plot, all right? And notice that there's one empty space, and that's just because we haven't defined the third. Right now, I'm going to copy and paste everything. So let's just copy and paste this. All right, and I'm going to say 313. Let's plot the scatter plot. So we're going to plot x comma y, and let's use, I don't know, let's use diamonds this time, just because we can. We're going to hold, because we want to make sure that the function is plotted on the same plot as the scatter. We're going to hold off, and let's just rename this scatter and exp of x. All right, so let's run it. A lot of code going on here. All right. Just going to execute it. All right, and here's what we get. Whoever picked this problem decided that it looks like that the markers are going to fall exactly on the line. And a little bit later in the course, when we start doing these sorts of approximations with polynomials, we can take the data, we can plot it on a graph, and then what we can do is we can also plot the polynomial function that we're going to extrapolate from that, or exponential, or whatever regression that we're going to get. And we can determine whether or not it's going to be a viable model for the data. So that's what we're getting to. But that's why we're doing this right now, is so that way we can kind of get the prerequisite coding materials for that. Okay, so pretty cool. So hopefully that helps you to understand scatter plots, their significance, their use, and how we're going to implement them, as well as being able to use the subplot function, which I think is really cool to being able to compare. All right, one last type of graph that we're going to look at in the next video, we're just going to quickly look at three-dimensional plots, and then we're going to look at two videos where we're going to be reading and writing to files.